This question is about the first 30 elements in the periodic table, and we'll do this question fast. 78% of clean dry air is nitrogen. Alright, has atoms with electronic structure 281, has to be in group 1 if you want to quickly look at it. And yeah, what is it? I think it's sodium. Sodium. Extracted from hematite, they're talking of course about iron. Forms an oxide with a giant covalent structure, silicon, I guess. Is the gas with the slowest would mean heaviest, so that has to be chlorine. Has an anhydrous chloride which turns pink when water is added. That's a test for water as well. They're talking about cobalt. Has aqueous ions which form white precipitate with silver. Silver ions will give you halide precipitates. Chlorine will be white, bromine will be cream colored, and iodine will be yellow. So we have chlorine, that'll give us white precipitate. So, well, chlorine again, right? It's a pretty popular element these days, isn't it? Forms a blue hydroxide which dissolves in aqueous ammonia. That's not even a question. When you hear blue, you're talking about copper, and what's a hydroxide? Copper hydroxide. Copper. Going for Cu, but copper is added to molten iron to remove impurities in the steel making process. So notice how they're saying steel making process. What are you trying to remove when iron is extracted and you're trying to make steel out of it? So you're trying to reduce the amount of carbon in it by passing oxygen over it and letting the carbon burn, turn into carbon dioxide. So that is oxygen. You just pass air over it, but they're talking about one of the elements, right? Is used to galvanize iron. And yeah, zinc, why not? Alright, state symbols. Magnesium carbonate. Carbonates, most carbonates aside from like sodium and potassium are solid. Of course, aqueous. And then we have water, which will be a liquid, and then gaseous. Easy question. Alright, let's move on to the next bit, which is complete the dot and cross diagram to show. Complete the dot and cross diagram to show the electron arrangement of the ions in magnesium chloride. So they've given us 2 chloride ions, and the easy part is, I guess, the charges on them. And that's 2 plus. Alright, magnesium has an entire shell we need to draw. And we'll put X's over here because X has already been highlighted. It lost 2 of its outer shell electrons, so it has 8 in the shell underneath it, which we drew. Alright, let's see if we can make a eye-pleasing looking circle around it. Okay, that's horrible. Not my strong suit. Okay, that's 1, 2, 3, 4. We have to draw dots. And guess what? The missing electron from magnesium is drawn over here. Okay, and I'll just quickly do this. Alright, pretty straightforward. Let's just move on. We have to make the same thing. I like how now they're asking for dots and crosses for each. So dots and crosses are very important now. Alright, complete the dot and cross diagram to show the arrangement. That's kind of easy. So I'll keep oxygen in X. Oxygen shares 2 electrons, and carbon has Yeah, for some reason, sometimes things just don't work, like my pen. All right, x, 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 x. You know the drill. Make this a little more prominent. All right, let's move on. Describe how the graph shows that the rate of the reaction decreases as time increases. Well, as time is increasing, the gradient of the graph, I said gradient earlier already. Gradient decreases as time progresses. Explain in terms of particles why the rate of this reaction decreases as time increases. As time increases, the concentration of particles of, I guess it's better to say, reactants decreases, which results in a lower, I should say results in, but well, results in lower frequency of collisions. Voila. All right, on the grid, draw the line expected when powdered magnesium carbonate is used. Powdered, so that surface area is higher, so it'll be a faster rate of reaction. So they're not changing anything else. So what will this look like? All right, it'll start off fast, but it'll end at the same peak. Like that. Just carry that forward, whatever. Right? I think that's the important part to show. All right, let's move on. Calculate the number of moles of HCl. So moles is equal to concentration times volume. The concentration is 0.04 times 0.025. That comes out to be 0.01 moles. 0.01 mole. Okay, let's give ourselves some more room. Some fancy colors. Go with this. Actually, let's go with this. Determine the number of moles of carbon dioxide. So carbon dioxide, we figured out HCl. So what's the ratio between HCl to carbon dioxide? Carbon dioxide for HCl, equation says 2, carbon dioxide 1. So 0.01 will end up giving me 0.01 will end up giving me 0.005, and that's the answer. Half of that, right? Not too complicated. Okay, and calculate the volume of this carbon dioxide. That's easy. Volume will just be moles times, do we need it in centimeter cube? Yes, we do. 24,000. Should have changed the color. That's going to come out to be 120 centimeter. The high temperatures in the engine allow nitrogen from air, nitrogen and oxygen, I should have said. I'll just add it here. Nitrogen and oxygen from air to react. Nitrogen dioxide causes respiratory problems. State one other adverse effect of nitrogen dioxide. Well, that's going to be acid rain. Forms nitric acid in water. Okay, let's move on. Let us see. Let's see. Name the type of reaction which occurs when substances is heated and break down into simpler decomposition. Weird. Okay, heat of the exhaust gases. The heat, right? Heat of the exhaust is from urea. All right, that's thermal decomposition. So let's say that. Thermal decomposition. Pretty fun. Complete the chemical equation to show the formula of the other molecule that is formed in this reaction. So if ammonia comes out, you're left with what? And so it's a hydrogen left. CO is already here. And I think one more nitrogen. Oh, okay, didn't see that. So one nitrogen, so something like HNCO. I guess we don't know what this formula is. I've never seen this molecule. Doesn't matter what order you put it in. Yeah. Okay, let's move on. State the test for ammonia. Easy peasy Japanesey. What is it? Damp red litmus paper. What's going to happen to it? It is going to turn blue. All right, next part. Let's give ourselves more room. Balance equation. Balance equation. 12 hydrogen. Wow. Okay, we have 12. No, 24 hydrogen. They're not. Yeah, 24 hydrogen. So 24 divided by 3 is 8. 8 over here. And 12 oxygen, so 6 over here. And 8 and 6 are 14, so I need to put a 7 over here. And I think we're good. State how the equation shows that nitrogen in nitrogen dioxide is reduced. Nitrogen in nitrogen dioxide. So what's happening is nitrogen dioxide is turning into nitrogen. It's losing oxygen. That's how I know it's being reduced. So there's a loss of oxygen. Pretty cool. State the meaning of the term redox. It is when oxidation and reduction happen. Okay. Calculate the mass in 135 moles of urea is stored in the tank of the car. Calculate the mass in kilogram of the stored urea. So what is the MR for this? I know nitrogen is 14 and there are 2 hydrogens, so plus 2. So this part is kind of dealt with. There are 2 of these, and there's a carbon and an oxygen. Carbon is 12, oxygen is 16. The MR comes out to be 60, and multiply that by 130. So 135 times 60 will give you the mass, and this is 8100, and that's 8.1 kilograms. So far, it's pretty easy. Another oxide of nitrogen formed in car engines, nitrogen monoxide. Name the gas formed by incomplete combustion of the fuel, carbon monoxide. No questions. carbon monoxide. Name the two non-toxic gases formed. So what it ends up producing is carbon monoxide. Instead of naming it, I'll write down, but you have to name it. You'll have to write down the full thing. Right? Let's move on. The diagram shows the apparatus used in the production of electrical energy in a simple cell, so essentially a battery. The zinc electrode dissolves in the electrolyte, forming zinc ions. Draw an arrow in the diagram to show the direction of current flow. So zinc iron, Po, So, Ka, Mal, Zittel. Zinc is more reactive than iron. This will discharge. Electrons will travel from here to here. Electron flow, right? Not current. So electron flow will travel from left to right. So far, so good. Write an ionic half equation for the reaction. So zinc is turning into we got zinc 2 plus, and it does that by giving out 2 electrons. The reading on the voltmeter can be increased if either zinc or iron is replaced by another metal. Name a metal that can replace zinc and increase the reading. So you want a more reactive element than zinc. So I want to say aluminum, magnesium. Let's go with magnesium. Potassium, anything above zinc is fine. So let's go with, I want to go with magnesium. And I want to go below iron in the reactivity series, so copper. I like copper. Okay, name the reactants in a fuel cell. Fuel cells are used to generate electricity, and it's a nice color. Okay, almost. Hydrogen and oxygen. Hydrogen and oxygen. Name the waste product. So-called waste product is water. Continuing with electrolysis, name the process which uses electricity to break down aqueous molten ionic compounds. Aqueous molten ionic compounds. It is called electrolysis. Explain what the ionic compound needs to be aqueous or molten so that they can conduct electricity. It's better to say so that they can conduct electricity. Electricity, I think I'm misspelling something. We shall move on. Name 3 substances which are manufactured by passing electricity through Brin. Brin is highly concentrated sodium chloride solution. I think they get it from seawater or somewhere. And what they produce is hydrogen, chlorine. You take hydrogen and chlorine out, and what you're left with at the back, because you know for concentrated a solution of conc, a solution for conc NaCl, what's going to be discharged? Well, it'll be hydrogen from the positive. It's a solution, so it has hydrogen. So hydrogen will be discharged, and from this, chlorine will be discharged. So what are you left behind with? You're left behind with, well, sodium, and there's also water, so the OH. So what's the third thing that could be produced? Sodium hydroxide. Fun, right? Name a different substance formed when molten sodium chloride is used instead of concentrated sodium metal to be formed. This is kind of the question is simple, but it's phrased in a way where it can really confuse you. You know, I think if they hadn't said Brin, I think a lot less people would have problems. But it's a general electrolysis question. Let us move on. Name the type of chemical reaction which forms short chain alkanes and alkenes from long chain alkanes. Sounds like you're breaking them down. So breaking down of long chain to smaller chains. I think that's called cracking last time I checked. Write the chemical equation for the reaction. 10 carbon atoms. It forms ethane, ethene, ethane, ethene as the only products in this reaction of the chemical reaction. That's interesting. So decane would be C10H22, and this will give you C2H6 and C2H, what is it? C2H6 and C2H H4, right? Now there's 10 over here, so this should be 10. This has more hydrogen as well, so this has to be less. So this can be 50-50 because I can't have like 5/2 and 5/2 over here. Of course, they want like a whole number. And I'm just thinking from the top of my head. The other thing is this has to be less because this has more hydrogen, right? Just thinking out loud. And I'm willing to bet this is only one and this is the rest. But let's go with 10. So this is 4 of them. 4 carbons are here and 6 carbons are here. So for 4 carbons, I'll need to put a 2 over here and a 3 over here. So 6 times 2 is 12 and 4 times 3 is 12 as well. So I'm getting a bad answer, right? I'm getting 24 hydrogens and I only have 22 hydrogens. So this can't be it. So I'll give it less, even less. Wow, clean. I will give it 1 over here and 4 over here. 4 times 4 is 16 and 6, 22. That's 22, so I'm getting 22 again. So pretty easy. Let's move on. I feel like I do think these are very easy questions, not myself, but I think even my students would find these really easy. But I'm just all of a sudden thinking that one kid who's watching this and going like, how is this easy? What's wrong with them? Sorry, man. Ethane, I think it's pretty easy. At least after the explanation, I hope you find, guys, I think everyone, I hope, finds it easy. Ethane reacts with chlorine at room temperature. So this is a substitution reaction I think they're referring to. Chloroethane and one other product. Name the other product. Well, that's HCl. State the condition needed for this reaction to take place. You need no conditions aside from UV light. Moving on with life. Ethene reacts with chlorine as well at room temperature to form dichloroethane. State why this is an addition reaction. What an absolutely brilliant question. I'm being sarcastic, but the reason is it's only one product, so it's adding together. That's what addition means when it comes to chemistry, I guess. Not I guess, I know, but it's a deal with it. I don't know. Addition. Oh, why am I saying addition? I meant, sorry. I'm just defining it. Only one product is formed. Only one product is formed. All right, I think it's getting very routine. What do we have? The bonds needed to be broken are these bonds, 1, 2, 3, 4, and this. So let's put that down. All right, we have, oh my god, we have 1 carbon-carbon double bond plus 4 carbon hydrogen bonds and 1 chlorine-chlorine bond, the values of which are carbon-carbon double bond is 610, 4 carbon-hydrogen bonds, each with 410, and chlorine-chlorine is 240. And the total is 2490. Okay, moving on. Use your answer to step 1 and the energy change for the reaction to determine the energy released when bonds are formed. Alright, so enthalpy change is broken, anything broken minus anything formed. We figured out what broken is. It's 2, 4, what is it? 90. This is minus 180. And formed, what is formed? Now what's formed is 4 carbon-hydrogen bonds, which are 410, plus 2 CCl bonds, let's call them X. That's what we have to find out. And yeah, simple math at this point. All right, I think I'm doing it directly. We just need to know formed, like, what is this? Casual. Freaking casuals. All right, so we could have done it directly, but this is the thing. They just want us to, do it everything step by step. And this is a 1-mark question in an MCQ. Why do I have to do it? I don't know. I think people end up getting confused or end up making more mistakes. Anyway, formed, let's call that X, fine. And this comes out to, I think you can do it orally. It is 3. Use your answer in step 2 and bond energy values to determine the energy of this, what essentially we had, right? Use your answer. Okay, so bonds formed, the energy of all the bonds formed as we know it, but what bonds are formed? There are 4 CCl bonds, which is 410. At this point, I'll never forget this value, and 2 Cl bond. Let's just leave it like that. And this is, let's just put the answer directly, I think. CCl is 340. That's our answer. Esters are a family of organic compounds with similar chemical properties. They can be represented by this formula. State the name given to a family of organic compounds with similar chemical properties. And they're trying to ask us for the homologous series. You have no idea how much richer my life is because I know the word homologous, right? I think it's just absolutely brilliant. Explain why members of a family of organic compounds have similar chemical properties, because they have the same functional group. It's called functional group because that's where the fun's at. Functional group. Of course, I did want to say it has the same functional group, right? Anyway, let's move on. State the name given to the formula. State the name given to the formula, such as this one, a general formula. A general formula. Black Wigos. Is it me? The question keeps getting funnier and funnier. Determine the value of N in butyl propanoate. But means 4, prop means 3. So it should have a total of 7 carbons, so N is 7. Wow. I think it's getting funnier. All 4 of the esters in the list are liquids at room temperature, okay? Name the technique that used to separate ethyl propanoate from a mixture of 4 esters. You'll separate them because they have separate boiling points, so you'll use a fractional distillation method. Pretty cool. Life is good. Fractional distillation. Name the substance and draw the structure. All four esters can be made by reacting different alcohols with the same substance. Name the substance and draw the structure. Show all. Okay. So they're all ending with propanoate. So I think we need propanoic acid. This is easy. Ain't she sweet? Seen her walking down the street. So I ask her very confidentially, ain't she sweet? This song came to me because of the color I chose. Name the alcohol used to make methyl propanoate. Methanol. Ain't she sweet? State the terms used to describe substances with the same molecular formula but different structures. Different structures, same molecular formula. They're asking a lot of things. Isomers. Name two esters with the molecular formula as propyl propanoate. Okay, so I like this question. Propyl propanoate would have 3 in the alcohol, 3 in the acid part of the ester. So you could have 2 in the alcohol and 4 in the acid. That would give you ethyl butanoate, butanoate, and now you can reverse this. You can actually have like 1,5 as well. You can have a lot. You could have methyl pentanoate, but I'll go with butyl ethanoate. We're good. But some other possibilities include, I think we can go with methyl pentanoate. Anything is possible. Any 2 from these 4 will work. Any 2. Pentanoate, because, and pentyl methanoate will also work. Methanoate. Moving on. Polyesters. Complete the diagram to show, okay, this is the acid part. They've given us plenty of room. Very generous. Very generous. Okay. Remember to flip it. And reading all of the atoms and all of the bonds and linkages. So we'll finish it over here like that. And okay, done. And the type of polymerization, condensation. I wish this question ever helped me in my life. Name a polyester. Terylene. Ain't she sweet?